Hi class, today is going to be day 6. We're going to start inputting data into the calculator, and we're going to do some modeling or regressions to figure out what would be the best type of equation to fit our data. So what we're doing today is regressions. It's just really what is the best fit. We're going to look at different models. We're going to look at exponential models, and we're going to look at logistic models. So your calculator is set up for all this. So we're going to use a stat key. The stat key is right here on the calculator by the arrows. So, and we're going to input all the data. All our x values would be go under L1, and that's this screen over here. And I'll bring it up in a minute. And all the y values go into L2. They must match the number of entries in each column. And if you have data already in your calculator, we use the clear key, this key right here, not the delete key. Do not use the delete key, this key right here. That delete key will delete the column, and I'm going to have to fix it on your calculator. So here we are on the calculator. What I'm going to do is hit the stat key, which is right here. I'm going to, in edit, I just hit enter. And I have my L1s and L2s. If you don't have L1 and L2, let me know. I will fix your calculator. I already have data in here. I don't think I want to use this data, so I'm going to go to the top of the column. I hit clear, I hit enter, and it clears the column. If you want to delete an entry, that's when you hit the delete key. So I want to delete 64.4. That deletes it. That deletes it. But if I want to clear the whole column, don't hit delete, hit clear, and hit enter. And this is how I put information into the calculator. L1 is all the x's. Let's say 1, enter, 2, enter, 3, enter. And the y's here are maybe 9, enter, 8, enter, 7, enter. When we're done, we could do regressions. And the way we get regressions, they are also under the stat key. So I hit stat, and I move it down. I move my arrow to the right. I could do all these different type of calculations. If you've ever had a stats class before, or even in algebra, we've done these regressions. We have a linear regression, a quadratic, a cubic, or quartic. Another way to do a linear regression, a natural log regression, an exponential regression, which we're going to use, and then power we're not going to use, and logistic. Those are the two we're going to use. So when I use a exponential regression, and it goes through this whole list, it says I'm using L1 and L2. You don't have to use L1 and L2. You can use different things. I got to move it down to calculate. I hit enter, and I get all this information. The general equation is a times b to the x. Here's the a value. Here's the b value. And r squared help determine how strong of a model it is, if it's very accurate or if it's not very accurate. This is a negative regression, so it is a negative correlation, and this r squared is just that value squared and tells you how strong it is. But I could have done a stat calc, and I could have done it to a logistic by moving it up to b. I don't know if it'll work for just having those 3 points in there. I might need to have more than 3 points. So now when you calculate this, it's going to take a while. A logistic model takes longer to calculate. It might work, it might not work. Okay, it worked. Notice there's no r and squared and r value here, but I have this formula, which is a little bit different. Let's see if I can pull this over a little bit. I'm going to draw, bring up the calculator again. This formula is not our c over 1 plus ab to the x. It is y so I can draw. Won't let me draw on this. I'll bring it back to the other page. It's a little bit different formula. It's the one with the e in it, and it's raised to the negative bx. So c is the most important one. That's the cap value. That's the maximum value. A is the coefficient in front, and this exponent b goes in here. So it's really negative b, so it's negative of this b, so it would be a positive in this example. So everything we're using underneath the stat key, stat edit is to input the data, and stat calc is to calculate our regressions, whether it's going to be exponential or logistic. So we're going to input to this table, enter our L1s and L2s on the calculator, and a couple things. One, the hardest thing about this process is actually typing everything in correctly and not making what I call a fat finger mistake. The other thing is we never use the calendar year. So this is our L1, this is our L2, because X input for these type of problems is time, in this case years. We never use the calendar year. So 0 represents the year 1985, but I never use 1985. I call it year 0. And at the end here, this is year 1993, which is 8 years later. So I always readjust it based on what do I want to call the initial year. The initial year will always be x equals 0 or t equals 0, and that goes in the L1 column. So here I am in the calculator again, the blank screen. I'm going to hit the stat key, edit, and I'm going to put all these, well actually I'm going to clear out this stuff by hitting the clear key, enter, arrow to the right, clear, enter, and L1s are all the t values, and they were 0 through 9, so I could just do 0, enter, 1, enter, 2, enter, 3, enter, 4, enter. So I got everything here, 1, 2, 3, 4, 5, 6, 7, 8, 0. And now I have to come over here and input all the populations of the state of New Jersey from 1985 through 1993. I'm going to pause the video to do this. Okay, as you can see, I entered in all the data. I think I was pretty careful. This is the hard part, not making any mistakes. Your L1 and L2 columns must match in data. You can't have more in one column than the other because when we do these regressions, it's matching X's and Y's. L1s are X's, L2s are Y's, and they do match. So now I go ahead and do a regression. So I can go back to stat, go to calc, and I could do a get to 0 and do an exponential regression and move it down and hit calculate. And there is the equation. I'm going to do it to 3 decimal places on the A and 4 decimal places on the B. You can see it's pretty strong, but this is the idea. This is an exponential growth because you can see it's a positive R and the B value is bigger than 1. Here is my exponential equation based on the model that the calculator gave me. And you could see that the population by the model is starting at 7.585 million, and it is growing by about 0.45% per year. Now I'm going to do the logistic model by hitting stat, moving to the calc, and moving it up to logistic. I'm going to hit enter. I'm going to move it down to calculator, and this is going to take a while. It's not as quick as the exponential. It's going to take 5 or 10 seconds. You can see that it's thinking, oh, that was pretty quick. My calculator on my computer is a lot faster than the handheld calculator because I have a lot more computer processing speed. And here's my equation. The C value, which is important to me, is right here. That goes here. The A value is this coefficient up front. And then this B value is right here, and it's going to be negative bx, raised to the negative bx. So I'm going to use 3 decimals on A and C and 4 decimals on B. So going back to my model, y equals this big old fraction bar, 13.714. 1 plus A was this tiny number, E raised to the negative 0.0102x. These are my two models. Another thing that the calculator can do is actually graph the data. So if I go to my y equals, and there's nothing in here, I could come over here and turn on plot 1. And most likely plot 1 has already has been preset to graph the points L1 and L2 and do zoom. And I'm going to do number 9 here. Zoom stat, I'm going to hit the number 9. And there are the dots for the population for New Jersey. And you can see maybe there is an exponential trend to it, but maybe it's logistic. Here's my exponential equation, and if I hit the graph now, it's going to do the dots from the L1s and L2s, and it's going to put this curve on the same graph, and you can see the exponential is not a bad, I know it looks linear, but it's actually curved, but the exponential is not a bad little graph. Now I put in the logistic model, and I'm going to turn off the exponential model. I'm going to graph this, and you can see this one is okay too. If I put them both together, they're both very similar in this small little window. They're almost on top of each other. We're going to make this window bigger because this window is very small. I can make this is only like 9 years. Let me make it like 100 years. And let's make the population max. Let's make it 0 for the min and let's say 20 for the max. And there are all my dots. And you're starting to see that the exponential model is bigger than the logistic model. And we can go back and make a different window, but I'm going to go back to my worksheet. And it says, estimate when the population in 2018. Well, 2018 is 33 years later, so I'm going to plug 33 into both of these equations and see what I get. So I put these both in the calculator, and you can see that 33 years from 1985, which is 2018, I get about 32.5 million people in New Jersey by the exponential model, and I get 8.7 million people for the logistic model. To me, the logistic model this makes more sense. Okay? 2018 is come and gone. There's no way there's 32 million people living in New Jersey. It's probably around 9 million. So the logistic model takes into consideration that, yes, we are going to grow in population every year, but the trend of growth is going to slow down, and we're going to max out. And in this case, our number on top says that the maximum population for New Jersey will turn out to be a little bit less than 14 million people. Now for this next part, part D, I'm going to see when I should get 10 million people in New Jersey, what year. So I'm going to make y equal to 10, and I'm going to solve both of them. Before I go on, I made a mistake. I re-put this in my calculator. I must have didn't have enough zeros. The exponential model turns out to be about 8.8 million, and the logistic is about the 8.7 million. So at 33 years, they really are both about the same amount. But I want to show you on the calculator when we go deep into the future, more than 33 years, that if we went like 300 years for the time, that the exponential model is going to grow beyond what is capable. Now for this time, I did put in 300 for my x value for the time. And in 300 years, New Jersey has 29 million people, which might be right. Who knows? But the legitimate model has only 13.2, getting towards that max of 13.7 million people, which most likely is a more accurate model. The farther you go into the future, the exponential model is going to go on and on and on greatly, while the logistic model is going to start to level off to that maximum value. Okay, as you can see, I did it where I made both models equal to 10. I did my little algebra work. I got one time it was about 61.5 years, which will give me the year 2046. And the logistic model took a little bit longer, about 76 years, which is the year 2061. They're pretty close, but the logistic model will take longer because even though it's growing, after it reaches some point, it is the rate of growth is slowing down. Okay, ask questions. This isn't too tough. The hard part is just learning what the regressions do. Okay, thank you for watching this video.